Super 7. Yug.
Yeah, I'm Yug, and I'm in 7th grade, and this is my second year in Team Super 7.
Hello, I'm Chetan Bisht. I am an engineer, hardware design engineer in Apple.
So, my first question for you is, what are some cool and interesting projects you have accomplished throughout your job?
Okay, so let's see. In last couple of years, uh, do you guys play games on computers?
Oh, yeah.
Mm-hmm.
Are you familiar with graphics cards?
Yep.
Yep. Yeah.
Okay, so Navi 31, Navi 21, AMD graphics cards, or
Mhm.
PS5. Okay, so I build chips for those
Very cool.
consoles and graphics cards. Yeah, this it's pretty cool, huh?
Yeah. So,
Yeah.
what is the process of accomplishing those graphic cards throughout your job?
Uh, the process is so what the team did was to actually build the chips for those, right? So these graphics cards actually use what you call the uh, chips, and chips are specially designed. Um, I don't know how much familiar you are with the chip design process, but these are special circuits that have many logic circuits inside. And I think in your robotics you use chips too, right? Those cards that you use have
Mm-hmm.
computer chips
Yeah.
which are
Yeah.
programmable. And so you can just think of those chips that you use for your robotics that you program, just take a huge version of those chips, and those are the graphics card chips we're talking about. So designing those, the process is just a long process, takes 2 to 3 years. There's a big project uh, execution that goes on. Eventually, it becomes a design that goes into fabrication units that actually build chips. So it's a process of planning, putting the plan in place, writing specifications, designing, testing, and then eventually sending it for manufacturing.
Uh-huh.
And then when the manufacturing it comes back, then we test it again, and we figure out whether there's any problem, everything is okay, and then sales. So this is the overall process.
So, overall, along this process, how long does it take to completely manufacture the part?
It takes about 3 years at least before you start thinking about what you're going to put and what actually comes out in consumer hands. So let's say you want to build a chip that the gamers want.
Mm-hmm.
If you start designing today, which is 2024, these graphics cards will be out in the market in 2027. So you have to think that much in advance. Anything. So right now I'm not in AMD. This is a chips that I'm talking about AMD, but currently, for example, I'm working for Apple computers. Same thing there. So chips that we start today will be in the iPhone in 2028. So the projects typically in the industry run for 2 to 3 years,
I see.
which is very typical in hardware design.
Mm-hmm. So I know communication plays a very important role in robotics teams. How could you talk a little bit about how you communicate with your team on a day-to-day basis?
Yes, similar to your robotics team, I guess you guys have team meetings, personal face-to-face meetings. When you cannot meet face-to-face, you do calls like these on Google, or chat with each other on the phone, or maybe what you use, Discord, or
Mm-hmm.
something like that. So very similar processes are what you see and do in the industry. There are regular meetings, there are regular meetups, and then there are emails, and then there are devices, different communication devices that we use. Very similar process that you guys are following, just a bigger version of that.
Mm-hmm.
Yeah. So yeah, Samuel, I think we already talked about the fact that it takes 3 years for your chips to hit the market once they start planning. But to be successful in robotics, also throughout our season, we have to lay out plans. Like for example, in our month, we have our state championship. So if you want to talk about tools you use or anything that you do on a day-to-day basis to implement planning plans to be successful.
Yeah, I mean, depending on what these are huge projects. So, but ultimately, you can scale it down to what you guys are doing, right? So, what we're talking about, probably your team is 4 to 5 people, right? So the tools will be different for planning compared to the teams that we're talking about here, which is typically 1,000 to 2,000 engineers, right?
I see.
So you can use Microsoft Project for project planning. You can use Excel for just simple planning. You can use various different tools to take notes. I mean, there are tons of. It is not very. Uh, it is not a structured process. Whoever whatever they like can use. Eventually, everything has to go through something more common, like ultimately the status you present is through PowerPoints. So that's very common in the industry. Ultimately, you have to send a summary of through an email, which is also very common. But other than that, you can choose whatever tool you want for your own purpose. I'm curious, what do you guys use for your own planning?
We have a lot of different methods of communication. So for we usually lay out spreadsheets with like we have dates as the headers. So if we have like a big tournament or something approaching, we have spreadsheets with dates, and we know that like okay, this needs to be done by this date. Or we also use Trello, like a project management tool for like upcoming, let's say outreach events or something. We'll have like a item in the calendar to show like at this time we have this event. So
Mhm.
yeah, that really helps lay out
Okay,
everything.
so that's how you will. So pretty much that's how it is done in most of the industry, anyways. Something you can put data in, and then that can show you where you are with respect to your uh, so whatever plan you have made, and then there's a burn down chart, right, in the future, how you will
Mhm.
execute, and then you actually go and look at the reality and then make an adjustment. And
Yeah.
Microsoft Excel is pretty good for that,
Yeah.
basically.
We've seen also. So another thing is like in at least in our robotics team, we've seen that like having the ability to be adaptable to like changes and problems is really like important. For example, like our recent like league championship tournament, part broke on our robot that we had to fix, and we had to be able to quickly get all the parts we needed and replace it. So, have you like had to be adaptable to changes in your product or your job, like on like a spontaneous basis, make major changes or something?
Yeah, that's part of the project design. Um, it happens every day, every week, every month. Um, Depends on different levels. Um, Sometimes it could be like a complete revamp of the product because the market has changed. So that affects everybody, thousands of people. Everybody has to make new plans. Sometimes it's a very small software program that didn't work the way it was, or you have to use a new language or something like that. So that is from the level of an individual engineers all the way to the level of a what you call the leader of the entire project, or sometimes even the entire company. Right? Things do change, and depending on the new conditions, we have to make those adjustments. So the example you gave about your team had to adjust. So you are doing almost like a project. So that is exactly the same learning that you will take it to the real project in any industry. It doesn't matter which industry you go in, software, hardware, even no, not only technical but non-technical industries. Everything is exactly the same way, including
Mm,
services, for example.
yeah. So, and I think we talked about like software and hardware differences in that right now, but so in our team, for like in our robotic team, there's a lot of different stuff to get done. Like we have software people, we have hardware people, and then we have documentation people that we need to submit like a portfolio to our like our tournament. So we have people that work on making that specialize in that. So like, to what extent do you have people of different? I know like you are all engineers and like making one chip, but to what extent do you have like people of different skill sets and stuff working together?
Um, so documentation is pretty much required for everyone. So there's no separate documentation. I mean, it's part of being a good engineer to be able to document what you're doing, right? So that's because the person who actually has done the thing is the person who can document it best, right?
Mm-hmm.
So and then So besides that good habit of documenting for yourself as well as for the team, which is a key skill, right? So then,
Mm-hmm.
then the distribution depends on what kind of a project it is. If the project needs more hardware folks, then it will be staffed accordingly. So there's a big staffing plan. So if you're doing a robotics project like yours, um, if the components are pre-built for you, computer is already there, everything you just put in place, then you really need more software engineers to program it. If it was nothing existing today, you have to buy the components off shelf and figure it out. Then you need more hardware people first, then software. So something similar happens in the industry. Depending on what is existing, what are the specification you want to achieve, you actually make the resource planning.
Nice. So it's very like versatile and stuff in terms of that. Yeah. So I mean, I think in terms of what you talked, like all good engineers should be able to document. So yeah, we also do try to have everyone on our team like document, especially what they're doing. Because if a programmer is doing something, they might like the hardware people might not understand it. So we try to have everyone document to an extent their own stuff. Um, Another thing, this is kind of a thing with adaptability, but like, have there been a lot of times where you face like a major setback in the production of a product or something? Again, this is often have to be done in like our robotics competitions, where something just outright broke and we have to figure out what to do when we couldn't fix it or something.
Yeah, setbacks are part of any program. It is very common. In fact, teams have to be ready for that. And whenever things don't go according to the plan, you just put together uh, the team, all hands on deck, triage the issue, figure out what are the options, and then how to get out of it. So it has to be a team effort. It's setbacks are very common. It happens all the time. Um, so you have to also see if the setback. Not only you should figure out how to get out of a setback, but you should also figure out if this doesn't happen again, what kind of steps you can take. At least
Mm-hmm.
that problem is avoided. You can
Yeah.
have new problems, but the idea is to make sure that at least the issue that you solve right now, how could it? So one of the key aspects you should think about is what led to this problem, if there's a problem, and is it something that you can avoid by changing the process the next time. So that's one of the key aspects.
Yeah, I think that's definitely important because when something sets us back, we definitely try to like as like we fix it, but then we're also like what we can do to make sure it doesn't happen again. So
Mhm.
I think one question I was interested in, like you guys, your company produces the chips and things, but like so how does it work? Do you like once you produce the chip, do you work with other like hardware computer companies to get them implemented in those computers, or do you just like produce the chip flat out and like whatever hardware company wants, you can pick it up, or do you have to communicate with other companies often also?
It just depends on um, many different uh, business models are there. When I was producing chips for graphics cards in AMD, then it really depends on you produce a chip that, but then if you are producing it for PlayStation, Sony, then you go according to exactly what Sony wants. But if you're producing the chips for the open market, then you do what you want, and then the other people have to follow through. Different card vendors will put those chips. Uh, when I'm working and producing chips for Apple, then I'm producing chips exactly what iPhone guys want
Hmm.
or iPad folks want. So then it's completely inside internal, not to any external customer. So that it just depends on uh, what kind of a market you are targeting.
So basically, sometimes you're just producing them as like putting it out there. Sometimes you're working specifically for a company or a product towards that.
Yes, yes, that's right.
Um, Yeah, I think that's something that's really cool what you do and stuff. So I think we brushed a little bit on this, but like, how do you see like some of the hard skills, like soft skills that you use in your job, being like transferred to the field of robotics, like teamwork and stuff like that? Like, do you see that? Like, do you see a connection there for like kids in robotics to adapt to like skills used in your job and stuff?
Or if I were to do robotics, than how my current skills would
Yeah, like
do it.
how your skills would apply or something. Like how?
Yeah. So no, I think that's a good way to ask the question. Yeah, it will transfer directly. Anything that you learn professionally, we just already went through all the processes that happens in product design and robotics. If you're building a robot for, let's say, I'm sure right now the teams that are building robots, Tesla is building a robot, Samsung is building a robot, all these companies which are trying to build something. In fact, companies which do assembly processes build robots for car manufacturing. So building of those robots are exactly the same processes designs that is followed in any industry, including the one that I work on, software hardware. So they should apply directly. Now you guys are building a robot to compete. So for you, the customer is the competition is the market and customer is the judges. So other than that, it should be the same process. The skills should be transferable from one place to another.
Yeah, that seems pretty accurate. So, Yo, do you have any? I think that wraps it up for my questions. Yo, do you have any other questions?
So while following like an engineering design process, what skills do you like develop from following that during your work?
You have to explain that question to me again. So, what skills did I develop when I was developing these?
Yeah.
Yeah. So I started like you guys, knew nothing about it. So then, uh, the people who were working it ahead of time before me helped like figure out what I need to learn. So that's the process. So what kind of skills I have developed, programming skills I have developed, program management skills I have developed over the part of my career. Then, other than that, actual domain knowledge design. For example, if I'm designing hardware, then I have to understand what hardware is, digital design is. So that is all skills that you learn. So these are the engineering skills specific to the domain as well as specific to the product you're doing, but also non-specific like project management is very non-specific, so you can learn it from any program. Did I answer your question? Was is that what you were asking?
Yeah.
Okay,
So that wraps up my questions too.
thank you.
Do you have anything that you wanted to like ask us about or anything, or could you?
I just wanted to ask, how are you guys doing? Is it a good? How was your experience, and what stage are you in right now?
We're doing pretty good. So we recently just won the top award at our regional championship. So we're headed to the state championship in 2 weeks. So we're competing and we'll let you know how you do how we do. So thank you for your time on this call, and we definitely learned a lot from
Good
everything.
luck, guys.
Thank you.
Thank you. Thank you.
Okay, bye
Bye.
bye.
Bye.